So as I already told you, there are two inputs. One is the non-inverting input and the second one is inverting input. So the non-inverting input basically is positive and the inverting input basically is negative. So now I have explained you all about the difference amplifier or the differential amplifier. If at all we call an op-amp as differential amplifier, then the output of a differential amplifier has to be proportional to the difference of the two inputs, which means if I write V0 is the output voltage, it has to be proportional enough to the difference between the two inputs, which means V0 is equal to or is proportional to V2 minus V1. If this happens to be the equation, if V0 is equal to V2 minus V1, then this will not prove the criteria for an op-amp, because criteria for an op-amp happens to be the output voltage has to be very greater enough when compared to the input voltage, because it is strengthening the weaker signals. That means there has to be some gain which has to be multiplied to the input so that the output becomes greater. So V0 is equal to A into V2 minus V1, where A happens to be something called as voltage gain. So this gain, if I consider, V0 is equal to A into V2 minus V1, and as I already told you the definition for gain is output upon input. So if I write the equation for A, it will be equal to V0 upon V2 minus V1. So V0 is the output voltage and V2 minus V1 is the input voltage. So gain is equal to output upon input. So this basically tells us that the operational amplifier here is a differential amplifier.